So problem number 4, I look at it automatically, and I see that this right here is a division problem. Cool thing about division problems is that division problems are actually multiplication problems. So even though this is a division problem, I'm not going to solve it using division. I'm going to solve it using multiplication. So just a heads up, if you have a division problem, you have like A divided by B divided by C over D. This actually becomes a multiplication problem. All you have to do is get the second fraction and flip it. And so now you're going to get A over B times D over C. So as soon as you flip the second fraction, the C and the D, it becomes a multiplication problem. Or if you want to see it in another form, you'll have A divided by B divided by C over D. The way that you get rid of a denominator here is you do the reciprocal of C and D, but what you do to the bottom, you do to the top. And so therefore your denominators here cancel out, leaving you once again with the A over B times D over C. So a division problem is actually multiplication. Just remember to flip the second fraction. So if I want to do this, I'll have x squared plus 2x minus 24 over x minus 3. But now this gets flipped. So I'm going to make it into a multiplication problem with the x minus 3 now on top and the x plus 4 in the bottom. Okay, so now division turned into multiplication. Now I'm noticing my numerators and my denominators. I like the format of this denominator. Same thing with this x minus 3 and this x plus 4. The only issue that I have or that I see is this numerator right here. So I'm going to go ahead and factor out the x squared plus 2x minus 4 using my t. So that way I can have this in factored form where the negative 24 goes on the left side and the plus 2x goes on the right side. Again, this number has to get multiplied. This number here has to get added. So I need to come up with numbers that multiply to negative 24 but are going to add up to a positive 2x. So the numbers that come up in my head immediately are going to be 8 times 3 and 6 times 4, right? But it does have to be a negative, so that means that one of these numbers has to be negative. So I can say negative 8 times a positive 3. I can also say negative 3 times a positive 8, or negative 6 times a positive 4, or a negative 4 times a positive 6, right? And now I need to go ahead and add these. So negative 8 plus 3, is that going to add up to a positive 2? No. What about a negative 6 plus 4? Negative 6 plus 4 is going to equal to a negative 2. I don't want a negative 2. I want a positive 2, so that's a no-go. A negative 3 plus 8, that's going to be a positive 5. That does not match the positive 2. So negative 4 plus 6, that equals to a positive 2, which matches this up here. So my factors are going to be x minus 4 times x plus 6. So instead of putting x squared plus 2x plus 24, I'm going to replace that with x minus 4, x plus 6. So I'm going to rewrite my expression with my new factors. So I'm going to have x minus 4 times x plus 6. But keep in mind, guys, once again, that when you're multiplying fractions, you literally just multiply them straight across. So I'm going to go ahead and multiply this times an x minus 3. So now instead of having two fractions, I'm going to go ahead and combine them as 1. And this is what I have. So all I have to do now is cancel my common terms in the top and the bottom. And I see that I have an x minus 3 that's the same. And that's literally it. So that means that my final answer here is going to be x minus 4, x plus 6 divided by x plus 4. Okay, and that right there is my answer. Why? Because it says to simplify. And that's all I have to do. So even though it's a division problem and it might seem intimidating, it's actually, not that bad at the end of the day.